Now the another concentration term is molarity. What is molarity of the solution? It is number of moles of solute dissolved per liter of the solution is termed as molarity of the solution. And students, this part is, every topic is very important in every chapter, in every subject, but this is quite important. Molarity, normality, mole fraction, and then parts per million, and then whatever we discussed before this, that was also important, but molarity, you must know about this if you are studying in the class 12, or if you are the pass outs, or you are preparing for the competitive examination. Then what is molarity? Because many questions are asked on the molarity. So what is molarity? Molarity is number of moles of solute present or dissolved per liter of the solution is termed as molarity of the solution, and it is represented by the capital M. Okay, it is represented by capital M. So the formula of the molarity is M is equals to moles of solute by volume of solution in liter. Now we must know what is moles. Okay, what is moles of the solution? What is moles? Moles is represented by small n, and it is nothing, it is weight upon molecular weight of the compound. Are you getting? So molarity is number of moles of solute dissolved per liter of the solution is termed as molarity. The formula is moles of solute by volume of solution in liters. And the moles, what is the formula? If you don't know, if the moles are given in the numerical that we are going to discuss obviously, then if the moles is given, but if the moles is not given, first you need to know what is moles. How will you apply the formula if you don't know? Then moles, the formula of the moles is, first is it is represented by capital N, and it is weight upon molecular weight, weight by the molecular weight of the given compound. Now we can expand this formula. Yes, it is M weight of moles of solute by volume of solution in liter, and moles are termed as weight upon molecular weight. So here we can expand it, weight, that is represented by the small w, then molecular weight, that is also represented by the capital M. So don't confuse between these two, that which one is the mole and which one is the molecular weight. So molecular weight you can write in this way. Okay, so don't get confused. This is molecular weight and this one is molarity. Then volume of solution in liters. So here we are going to take volume of, because if we expand this, then we are going to take volume of solution in liter. Not in liters, we are going to take volume of solution in ml. Then if we have taken in ml, then we have to multiply it by 1000. So we are having the formula of molarity is W, that is weight of solute, into 1000 by molecular weight of that compound into volume of solution in the ml. If you are going to expand it, if it is directly given that such and such amount of moles are present in such and such amount of volume, then what is the molarity? Then it is very, you will be very lucky. But if it is not given, you need to know what is the number of moles, then you have to write the weight of the compound, then this formula will be very much helpful. So weight, W is represent the weight of the solute, M is, that is written below, okay, it is molecular weight, and M is, that is molarity of the solution, and volume is of the solution obviously in ml we have taken. Okay, so I will discuss one example. Right now I am going to discuss one example, one numerical based on the molarity. After discussing all the concentration term, we are going to discuss the numericals on all the concentration term, because numerical is very important. So we are going to discuss a numerical. All right. Now we are having a numerical that is based on the molarity, and what it is? It is calculate the molarity of the solution obtained by dissolving 4 gram of NaOH, that is sodium hydroxide, NaOH in 2 liters of water. So calculate the molarity of the solution obtained by dissolving. How much amount is this given? 4 gram of NaOH in 2 liters of water. So it is very direct question. So we can apply directly the formula. M is equals to, M stands for the molarity, and M is equals to W into 1000 by molecular weight into volume in ml. So weight that is given, how much amount of weight is given? 4 gram, and volume is 2 liters. Then molecular weight. Molecular weight is not given. Then how will we define it, or how will we find it? Molecular weight. Molecular weight, here it is given in the question, 4 gram of NaOH. Okay, not X compound is given, that we will be not able to find the molecular weight. The compound is clearly given to you, that is sodium hydroxide. So the molecular weight of sodium hydroxide will be, I'm going to solve it, otherwise it is 40, and when we are going to solve it, then Na is 23, sodium is 23, O stands for 23 plus 16 plus 1, that is equals to 40. Are you getting? So 40 is the molecular weight of sodium hydroxide. Now we can apply the above values in the given formula, that is weight. W is 4 into 1000 by M, that stands for molecular weight. Please do not get confused between these two M's. One stands for the molarity and one stands for the that is for the molecular weight. 40 into 2. Now we are going to simplify it. Then 100 by 2, that is 50. Okay, so in this way we will discuss in the upcoming videos in the part 3, solution part 3. I am going to discuss many numericals that are based on all the concentration term, obviously the molarity. So in this way you will get a little bit idea of it. So this is the molarity of the solution. 50 is the molarity of the solution. Now we will discuss the another concentration term. Okay.